Hello everyone and welcome back to my messy lab. Today on the bench I have this Agilent Monster power supply. Model is 6032A. Is a system power supply capable of a really high performance as it can be used from 0 to 60 volt and from 0 to 50 amps, which is quite a huge amount. In fact, is 1 kilowatt power supply, fully programmable through GPIB. So, well, I purchased this because I need such power supply to feed my old vacuum tube radios, aircraft radios for future project. And since it's quite expensive unit, I purchased this one as non-functional. It has been declared that is not powering on. So before I plug it to the power supply, I will remove the top lid and see what inside. So let me do off camera, removing the screws, and I'll be back. So I have removed all the screws. Actually only the sides handle screws, since should be those screws which hold the top lid. So I'm trying to remove this with just one hand, which is not easy. And yes, here it is. Oh, well, actually the unit is quite dirty. Covers inside, it's really dirty. So I remove all the screws also of this shield, and I'll be back. So I removed all the screws of this shield, and I'm looking inside together with you. Huh? This is the first time I see it. Oh my goodness. Completely dirty. Yes, it's obvious that it has been used in a very dirty environment. So, even for trying to understand if there is something of obvious, well, oh, look at that. How dusty, big dusty is in. My goodness. Well, before doing anything on this power supply, even to try to see something of obvious, it's clear that it needs a very deep cleaning before doing anything. And since it has been declared that it's not powering on, so I need to check some fuses. I already have seen one here, which seems black, so could be blown out. But, well, with this kind of dirty, everything can be happening inside. So let's see if we can fix this. I have said the monster, because this is a real powerful power supply, and this is the HP controller card, and this is the current and voltage sensing board. Actually this one, the GPIB card, is also doing all the logics. So there is the microprocessor on. There is this unit has two level microprocessors, as I will show later. I have service and user manual, so I have all details. Front panel has only the interface, no other kind of logic processes. Yes, well, it's really dirty. So I'm just trying to see if there are some signs of leakage from those capacitors, but for the moment I'm not seeing anything obvious. But of course, with such dusty on, it's impossible to see anything. So let me clean it a little bit, so maybe we can see something better. So before I'm going ahead to the cleaning of this unit, I wish to show you something about the front panel. So the shape is not really bad. There are some stickers, residues, which I should be able to remove those. The glass is not so bad, so not badly marked or scratches, so it's quite good. All the leads are okay, no signs of heatings. The unit were excellently packed, I have to say, very safely. So I also have noted that the fuse seems blown, and in fact I have already measured with the ohmmeter, and it is open. So yeah, probably there is some short circuit on the primary section of this volt regulator board. This is the main board, and on this board are produced unregulated voltages which are regulated in the controller board. And yeah, this fuse actually it's supplying only one side of this motherboard, since the other one, it has been designed a different board with an inrush current limiting resistance that are over there. So those resistors, if I'm not mistaken, should be the inrush current limiting. And yeah, so the high power side, it is only enabled by release controlled by control board only after the primary supply start. So it could be that the power section should not be involved in this fault, hopefully, because there are some expensive FET here, FET in this below this heat sinks. Yeah, it seems that should be let's say straightforward, the inspection on the primary section here. So maybe a faulty capacitor, or maybe since this side is supplying the controller board, or maybe a short circuit in the second stage of voltage regulations circuits. So that also can be. As you can see here, there are some electrolytic capacitors that can be shorted out or leaky, badly leaking. Or maybe there is also something inside just coming from external. I mean, something that has been folded in because the unit were very dirty here. There are also some signs of mud, incredibly. Here there are signs of mud. So yeah, I don't know. Need to be taken apart everything, and I will also remove the lower cover here. Unfortunately, is missing one of the front feet, so the unit is tilting, and it's quite annoying. So I will manage to find another one. Yeah, let's take it apart and clean everything and see if I can find something of obvious. As you can see, I've just removed the bottom cover, but it doesn't help me very much since the steel is the frame, the chassis of this power supply, which cover almost everything. So I can see here some sign of eating, and I believe this is I don't know if you can see from the camera, this where is it? Sorry, here. This, it's almost brown, so it looks like it has been suffered from heating. So let's see what we have on the other side. Yeah, capacitor. No, sorry, this is a resistor. So yeah, that could be also because of it has been heated for a long time, since it seems that this unit has been on for a very long time. Well, by the factor of the huge amount of dust inside. You look at that. Everywhere is full of dusty. Everywhere. I think I have to remove everything till the chassis. So yeah, let's take it apart and see how are things inside. And these are signs of water. As I said, there was mud signs outside. So I believe, I mean, I actually don't know where this unit has been stored. Probably outside, we don't know. Look at that. Also here we have some signs of water and mud. Well, we will see. Let's go ahead. So after our first cleaning on the surface, when I go here with the brush and vacuum cleaner, I found that below the main board there is something that is coming out. It seems to be a screw. So what I want to do now is to, let's see if I can make it focus. Yeah. So what I want to do is to, sorry for this movement, I'm trying to keep some pliers. Okay, I eventually got it. And come on, focus. Let's see if I am able to, oh, it's so hard. Oh yeah, I've been able to remove, yeah. It looks like a rear screw actually. Here in the rear we have here on this, it's missing one of this one. It seems to be exactly this. Yes. Oh, look at that. So hopefully that is the cause of the fuse blowing. It's blown out. It's completely dark. Let me grab it. Yeah, completely blown out. Okay, I'm going ahead and clean more in depth, since I have seen here a residue that seems that something of liquid has been inside. So I think I need to remove everything from here and get a good cleaning before I attempt to power on this power supply. Let's go ahead. And eventually I found signs of liquids, but it doesn't seem leakage of the capacitors here, since I have already cleaned it a little bit here, and with just a glass cleaner it came out very easily, and it doesn't make any oxidation. I mean the typical oxidation of capacitor leakage. It seems that some kind of liquid felt inside here, and not only here I have to say, but in the wall power supply here, because there are signs also over there. There is a, you see a different color of the main board, and this is the residues of this liquid that I believe accidentally has been dropped in. So I think that I just need to go ahead and clean deeply and see if we can fix this unit, and has not damaged it so deeply that it can be even fixed. We don't know how deep is this contamination. So, and especially here in the digital board, what has been caused about because of this leakage. So yeah, let's go ahead. So going ahead with the instrument dismantling, I found also liquid signs in the front panel PCB, and that should be inspected more in depth. And yes, this is the main board that still is inside the unit, but next step will be to remove all the screws and taking apart. So let's go ahead. Okay, so now the main unit is out. So what I need to do now is to clean everything as best as I can and see the state of this main board. Let's check down here. They are not something that made me be a little bit scared. So, well, signs of brownish in here, as I saw before from the bottom, to be inspected more in depth, but all in all, it's not too bad. Well, signs of the liquid felt inside also down below here. Well, let's clean everything and let's see what we can find later, making some testing and see if we can figure out why the fuse that we're living here is it has been blown out. Okay, let's go ahead. Okay, so while I was cleaning, of course I have not finished yet, so while I was cleaning the board, I noted that something strange, and I will show you in a moment. Look at the plug. This is a typical UK plug. So if this unit it has been plugged in UK or in UK area, it has been plugged in to a power supply, a power line of 230 volts. But look at that, look at this, two switches, so it is set as the second one, so it's set for 120 volts. And we have another setting here, it's 120 volts, and there is another one in the back which is for 220 to 240 volts. So it is clear and obvious that this unit can be plugged in from the previous owner to 220 volts, but with the switching of the input set it to 120. So this could be another cause. We had the blown fuse here. So we have actually three possible causes that this fuse has blown out because of the wrong input selector position, and this of course can blow this. Because of the screws that I found down below, we don't know, and because of the huge amount of liquid that has been felt inside the unit. So very difficult to say right now which cause has been the main that has made this unit fault. But now with this wrong setting, since the unit is coming from UK area, I'm afraid that it's because of the wrong input selector position that blown the fuse, and hopefully the fuse has saved what all the rest that stay after it. So, but this can be checked only after I will have finished to clean this power board, and then I will check all the circuit one by one, looking for any shorts or other issues that can be caused by over voltage input. Well, let's go ahead. All right, here we are. I have cleaned the main board. To clean it, I have to say that it takes quite a while, since there are a lot of hidden corners and points that are not so easy to reach. However, Well, I can say that it's pretty clean. So what I will do now, I will grab the schematic because I want to make some tests on this board before go ahead and cleaning the rest of the instrument. So, well, I'll take the schematic. Okay, so this is the schematic of the input of power supply. So here is the line that arrived from the input filter. This is the input selector switches. This is a transformer, and these are the three mains supply. So this is the unregulated dual 15 volts that actually is as stated here about 20 volts. Here we have a regulator to have 9 volts, and here is the relay control circuit which enable the high power circuit that stay here below, up here I mean. So just let me move a little bit. So here is the inrush limit circuit, which there are the two limiting resistors, and here is the bridge rectifier with the capacitor, filtering capacitors. So all these live in the main board, the one that I'm going to check. So what I want to check before to go ahead is if this capacitor and diodes are working as they should. Same for the regulator here, and since here is connected directly into the main, and I'm suspect that this has been power to 220 volts with this switching setting for 110 or 120. So what I want to check if this circuit is still alive because of the overvoltage feeding on this unit. So, well, let's go ahead and check these capacitors and this regulator first, and then we will check this circuit. Of course, there is also another point. This is the fan, which is connected directly to the main as well. I mean, is in parallel with one of the primary windings of the transformer. So I want also to check the continuity of this fan, because well, with the over voltage can be also been damaged this. Hopefully this fuse it was as requested of 1 amps, so it's not a slow blow, so it was a fast blow. Hopefully the fuse blown out so quickly that not a lot of damages has been done inside here. So let's check those circuits and the relevant circuitry first, and then we can go ahead. So what I'm doing here now is to use an external power supply with a current regulation that is set at the minimum current, which is very low amount, let's say less than 1 milliamps. So what I'm doing here, I'm cranking up slowly the voltage here setting, and what I want to do is to reach the 20 volts Also a little bit more I have to say, since the capacitor are rated for 50 volts, and since the output of this circuitry is not connected. So what I want to do is to crank the supply here, the external power supply, up to, let's say, 25 volts, because what I want to check is that there are no leakage, nor the capacitor, neither other components in the circuitry. And since this power supply, it is has these facilities of low current, if there are some leakage, the needles will not rise up. And I like to use this old analog power supply, since it's very easy to see the needle coming up or remaining steady down below here, because there are leakage. So, well, I've already connected since a while, I mean several minutes that is on, and well, it seems I mean, so far so good. Capacitor is okay. I have already checked the other line. What I'm checking here is the dual I mean plus or minus 20 volts. So this capacitor I have already checked is okay. This one is the one that I'm checking right now. And yeah, these are these two capacitors here. So let me take a pointer here. So it's this one and that one. And both looks fine. So I will move the power supply to this point and check this capacitor and the functioning of this voltage regulator, and I will check as well the voltage here that is correct. So in the end we will have checked the whole circuit here, since if there is some shorting diode, for sure the power supply will not go up. So yeah, let's go to the next step. What I'm going to do now is to apply the external power supply across this capacitor here and monitor the output voltage here. So I will crank up to see the 9 volt outside here and look into if there are any leakage. And here is stated that should be around 21 volts the input. So let's go and see. And this is my setup. So I've already connected here to the capacitors, and both capacitors are down below there. Easy to let you see. Maybe yes. Come on, focus. Right. Yeah. So I'm going to crank up this, and let's see what will be the result. So slowly. So we are now at 10 volts, still with the current limiting to the minimum. Well, I was mistaken before saying that is below than 1 milliamps, because I have checked with the milliamps range here, and it reached 22 milliamps. Well, it's not very small, but can be also good for this purpose. And yes, we have our 9 volt, so it's a 9.10, and cranking up to 21 volts, right, like that. Here is the fine adjustment. Still we have 9.10 volts, so that looks pretty fine. So this is a really good sign. Well, now I'm going to check this circuit, right? So I will apply voltage across this and see if we have some faulty. Hopefully here there is a Zener diode which should have saved a little bit this circuit, so not sure, but well, let's try and see what's up. Okay, and this is my next setup. Here we have the power supply connected to this capacitor right here, and while I am monitoring the voltage across the Zener diode here. So what I will do, I will crank up the power supply, the external power supply, to the point where I will have the voltage of 7.5 here. Well, actually, this circuit, it should be supplied with maybe 50 volt, since all these in series give us the 220 volts, and assuming that the first and the second coils here are equal, so let's assume that here we would have 55 volts. So I will crank up to, let's say, 25-30 volts in this point, and in fact you see it's rated at 35 volts here. Well, let's limit us to 20-25 volts here and see what's happening. So let's crank up a little bit here while monitoring. So far so good. Voltage is coming up. That is a good sign. Okay. So, okay. And remember, yeah. Okay, you see, we are not able to go in over 7 volt, 6.6 actually, and this could be because of the Zener action that limit, I mean, will start to function this current limiting. So I should have to crank a little bit more, but I don't want to do it too much because yeah. So of course monitoring the current is no sign, so probably you can go up a little bit. Yes, and we have so 7.4 volt. Oh, I heard the click in the, yes. So release, as one release should click when reach the right, yes, again. So far so good. Signs are good signs. Okay. At this point, I wanted to check this capacitor here, which are the high power section that should not be involved in this fault, since the second relay here, it is activated only from digital board. I don't know exactly if it is this one or that one. So should not be involved in the fault, this train of capacitor here. So I'm going to show you here. In fact, if I move a little bit, Okay, here we have voltage selector, the switch, not the switch, this is the wire that should be changing the point, the position. This is the one of the relay that is supplied as soon as is applied, the instrument is power on, so this will be immediately switched on and is the one that we heard clicking. The second one, which is over here, it is only able from this optocoupler, but this is going to the digital board, so it is power on only after the self-check and everything is fine. So I believe that since could be possible that this power supply has been over voltage supplied, probably it doesn't have the time, the logic board to wake up. So I think that this section here, the power section, should not be involved in the fault. However, let's see in the next step. This is the other setup that I prepared to inspect if there are any over current requirements, and I'm cranking up till the maximum of this power supply, and it is 32 volts. Since these capacitors here are requested to run at very high volts, as you can see here we have another, oh, here we have another switch. Yes, this should be the wire. So before I was thinking that, let me check. I'm seeing with you, huh? So the first time also for me. Okay, sorry for this. Okay, so we have here this switch 1. Okay, so we have a third. Okay, yes, in fact there is another one. I will show you in a second. Okay, I understood now. So as I was telling that those capacitors are requested to work at full input line volts with this inrush current limiting resistor. So probably at the end here we will have let's say 300 volts or something like that. However, well, I'm going to supply just a little bit to see if there are any important leakage here. I will not apply 300 volts right now. So I think that since we are seeing that there are no leakage, what I need to do now is to go ahead to clean the rest of the power supply and connect everything and test. But before, I want to show you the other switch. Yes, this is the other switch that I should check on the user manual how to switch in the right position, because it's not indicated on the main board here. There are no figure about this, so let's see how should be set it. And the digital board is also finished, and it's clean it. As you may have seen, here it was very dirty. There was a liquid signs here, so everything is pretty fine. I have removed both the regulator and the capacitor. I have checked both and they looks fine. So let's go ahead with the other boards. So the next one is this controller board. Yeah, it's called controller board, even if the digital section is in the other board. And it's pretty dirty, as you can see here. Let's see, there, here, everywhere. This capacitor, well, I'm not sure if there's some problem or not. In the rear of this PCB is also full of dusty. So let me clean it up and check those two capacitors. We will see the schematic, so at which voltage should they run, and let's try to power on with the external power supply. Also, this board has been involved in the liquid contamination here. So what I'm going to do is to clean, as I've done on the GPIB board and the main board, just using a regular glass cleaner, since it seems that it's working very fine. And yes, always when I have to clean a bird, first of all I try to use the most delicate product that I have. And since the glass cleaner, for the nature of for the purpose that it should use it, it has been designed that does not leave any signs on glasses to leave them pretty clean and shine. So I like to use this kind of cleaning product because well, it leave parts without any signs or well, normally become pretty shiny, and this is something that I like. So let me clean it and see how will be the result. Yes, and this is the process of cleaning. So what I'm doing, I'm just spraying this glass cleaner, and with toothbrush I sweep on the parts of the circuit board that have been contaminated till the final result of cleaned PCB. So let me do it off camera and I'll be back soon. And this is the final result. So it's pretty shiny and clean everything. So now we can go ahead with the testing of these two capacitor and the relevant circuit. Actually, I believe that supplying those capacitors, we are going to supply the wall board. So let's check to the schematic and see how and if we can go ahead on this board. So what I'm going to do here first is to apply the external power supply here in order to supply all this circuitry and to check the output of those two voltages, since these voltages are the voltages that the 5 volts here and the 2.5 here are supplying the GPIP and microprocessors board. So this is very important that it's clean and it's working as it should, regulating at 5 volts. So we don't want to have here a different volt than 5 and here a different volt than 2.5, since it is important that we have a stable and clean supply for the digital section. So my setup is already done. Let me remove this from the front, and as you can see here, I have already connected to the power supply. So what I want to do is crank up a little bit, and as we can see, it's already stopped here. So let me increase the current. It's not going up at all. So let me check more further and in depth. So let's see why. So as you can see now, it's running as it should, since we have 20 volts of input, 83 milliamps, 0.8, and yes, I discovered why it was draining so much current, just because I've swapped in the reverse position these two. So, well, not good thing to do. However, I'm going to check the 5 volts and the 2.5 volts output. So let me take the instrument and check. Yes, so now the power supply is applied, and according to the schematic, we could be able to check the output of 5 volts and 2.5 just by measuring on pin 1 and pin 2 of U7 IC. And so we have 5 volts on pin 1 and 2.5 volts on pin 2. And I already have found U7 that is exactly here. So I grab my lead and I'm going to pin 1, and we have 5 volts. Moving it to pin 2, and we have 2.5. So good signs. The digital section power supply is alive. So I think that now I should go ahead with the cleaning of this and that board and the chassis. After that, I will reassemble everything, and we can test the functioning with all the boards reassembled on the unit. So let's see if the instrument will come back to life. There are some signs of contamination. I prefer to divide in 2 pieces by removing all the screws and the soldering these 2 wires, and open the board and see if there was some contamination below here. And we don't have such contamination here actually, but I prefer to be sure and safe in this way. So yes, I will clean the heatsink here, and then I will reassemble the board, and everything is back in place on this board. So the thermal switch wires are resoldered, so all the fins has been cleaned, and I think we can now put this in a part and go to the last one, last board to be clean, and And then we will go to the front panel, since I have seen that also on it there are signs of contamination of those liquids, which I cannot understand which kind of liquids are. Well, let's go ahead. And as you can see, also the last bird show signs of contamination. So what I need to do is taking apart all these heat sink by removing everything. So what I will do, I will mark each one in order to reassemble in the same order, and hopefully after this removal will not take so long time for cleaning. Let's go ahead. And eventually have managed to remove without the need of marking and the removing of those FET, sorry. So I just desoldered these two thermal switch wires from the board, and I left all the transistor on the heat sinks. So this is the result. Yeah, see how dirty it is, and the liquid contamination is here, and also I believe over there. Yeah. So let's give a deep cleaning on this bird. So having this transistor removed from the board, it's absolutely logic to test them before to reassembly, just in case they should have some faults. So these are the transistor on the schematics, and this is my setup for about the first one. And yes, this is good. So I will go ahead with this one, and let's see, it's not easy to do it with just one hand. See this one, sorry for the glare. Yes, this also is good. So I'm going to check this and yeah, and see how they are. Yes, and also this one appeared to be good. So let's try also this one. Let me test it. Okay. Yeah, also this one appeared to be good. So it's clear that now I can reassemble the unit after the cleaning. Of course, this testing is done with a very low current, so until we will switch on the unit, we will not see, we will not know if they really are good, but at least so far so good. Well, and also this bird is finished and looks, I mean, pretty clean. Okay, let's go ahead. So the next one is the front panel PCB. As you can see, is pretty dirty, and there are also signs of liquid falling inside. So what I'm going to do is to take it apart and to clean the PCB, and when I will remove the PCB, I will also try to remove this stickers residues, glue residues, in order to have a a more clean face for this power supply. So let's go ahead. Going ahead with the cleaning process, well, I've been able to remove almost all the stickers and glue residues, and so what I need to do now is to clean the sides of the front panel and the bezels as well, so the external bezel. And well, I have removed this one since I would like to see if I'm able to remove those scuffs on the surface. So yeah, let's go ahead and see the result. All right, so everything is ready to reassemble it. Front panel PCB pretty clean, and also the digits are shining, all the leads are shining, all the buttons are shining. I have polished the digit glasses, so front panel is pretty clean. Yes, ready to reassembly everything. And well, let's see the final result. This is the front panel assembled, so well, not too bad. The result is I mean, pretty good face on this power supply. So next step, it's this dirty chassis. So yeah, let's give it a deep clean, check this capacitor if still is in good shape. I want to check also the fan, if it is running, and how many noises doing. Yes, and then we will be able to reassemble everything and see if the instrument is coming back to life. And in order to reach all the corners of this power supply, I had to remove eventually also the rear board, which also was requiring a lot of cleaning since it was fully of dusty. I removed the fan, and I already have removed all the dust that was able to remove by vacuum. So this is the liquid residue, and so the contamination appeared to be quite huge. So yeah, this is almost everywhere. Okay, so now I'm going to clean and remove all this dirty and reinstall all the PCBs inside, and well, going to the testing. So we are not so far. Let's go. So look at that. In the end, I have removed everything from the chassis. Since the contamination was hard to remove, so I had to wash this chassis with water. So I had to remove everything. Now it's pretty clean. So now I can start to reassemble everything and go forward to the first testing. So yeah, let's go ahead. Cleaning the fan, I try to turn it by hand, and I heard a very nasty noise. Bearings inside probably are dirty and probably also dry. And this is how is this kind of fan inside. I had to remove this C-clip, this cover first, which live on this side, yeah, and this C-clip which hold all together on this small groove. Well, now what I'm going to do is to try to lubricate the bearings and see if I can fix the noise. Otherwise, I have to replace this fan. Well, let's try to lubricate and see how noisy will be. So, this is the result about the fan. Lubricating doesn't completely fix the noise problem, but it's almost fixed. So I'm going to reinstall the original one, since the lubrication that I've used is a regular motorbike chain lubricant, which is almost liquid when you spray it, and then became more thick like grease. So I'm using this kind of lubricant because when you spray it, it makes a sort of cleaning inside because it's very liquid. But after a while it became more thick and it became like grease. So, well, while I'm talking, actually I'm hearing that the noise is reducing more and more. So, well, for the moment I can say that is acceptable. I will see in the future if the problem will become more serious, so I will replace. But for the moment I'm pretty confident that this fan will run for more time that would have done without any clean and lubricant. So yeah, let's go ahead with the reassembly. Alright, so going ahead with the reassembly of the power supply. Before I install the front panel, I have checked more in depth the setting of the input selector switches, and I found that S1, it is showed here how it should be set for the voltage setting. So let me remove a little bit this lamp. So S2, which is these double switches for 220 volt, as it is the power line here, should be moved in the inner side, so they are closer one each other. So this is right. S1 should face this direction since it's right here, and as is stated here, that should be checked also W1, which is this wire here, and as you can see, hopefully, let's see if I can move a little bit. Yeah, so over there is 220, 240 volts, and the other one is for 100 to 120 volt. So setting is correct now, and I will install a new fuse, and then the front panel and all the other bird. So we are close to check this monster. And here we are, after so many hours spent to clean everything and reassembly. It's finally arrived the moment of truth, and the question arises, immediately. Will it work? Oh no. Okay, so cross finger. I will crank up my variac, and I hope we'll not see any magic smoke coming out from inside. And I'm also monitoring the output. I don't know what we will have as output, so I'm still cranking slowly, and so we are at 50 volt, and okay, so the rear switch is off. Let me switch on, because otherwise cannot do anything. And let's crank it up again, slowly. So far so good. Okay, we are seeing some signs of life. Let me see here. Okay, so let's go ahead, cranking up more. So far so good. And well, probably the digital unit, of course, is not running at the right voltage, since we are at 100 volts only. So the fan should maybe run, but yeah, it moves a little bit by itself. So let's crank up more. Really clicks. Okay, so weird noise. Okay, fan starts to spin. Some other clicks I heard. Okay, so for the moment it's okay, so far so good. 140 volt, no output. Yeah, fan a little bit noisy, but no problem. Okay, diode switch on over there. So it looks fine. Let me crank up a little bit more. 150 volt. Well, one arrow is coming out. Well, that could be all because the voltage is very low. However, yeah, it seems everything good. So what I want to do now is to switch off. No, let me crank up to at least 200. Okay, so no magic smoke. So 220 volt. Well, looks fine. So what I want to do now is to switch on directly from the line and see if this arrow will disappear. So let me make a different setup. So now it's connected to the line, and moment of truth. Okay, still error bar, but at least we have no smoke coming out. So I have to check the service manual and see what does this error mean. So looking at the service manual, the error 12 means that the DAC, well, it's the digital to analog converter that is performed in this board, should be fault. Well, actually what I found is it was this ribbon cable not well connected. So let's see what it's saying now. Yes, and here it is. So the unit is back in business, and now I should be able to move up, and look at that, 0.44, 0.45. Oh, very nice. I'm really happy. The unit is back in completely operating, seems. Of course, it should be tested with load. But if you think this the point where we start with the unit completely dirty and the contamination, blown fuses, so well, I have to say that I'm pretty happy with the result, since the unit is functioning, at least it's giving an output which is in accordance with what's shown in the display. Well, yes, it's quite good to see this result. So what I will do is to finish the reassembly and to test this unit with a load. Could be also nice. I have another project which is an active load, is to be bring back to life. So maybe could be for a future project, and then I can use it for test also this. But well, it's pretty good to see back to life. Well, and this is the final result. The unit is completely reassembled and looks very nice. So I still have to test with the load, but well, I will do as soon as I will have the right load for this monster power supply, since we need to be connected to a very hard load to test if the unit is functioning. So okay, thanks for watching, and I hope you have enjoyed this video. See you to the next time. Bye.